Okay, we're talking about multiplying algebraic expressions. Now we're going to do multiplying a monomial and a binomial. Monomial is those mathematical expressions consisting of only one term. So for example, let's say a here, one term only. Binomials are those mathematical expressions consisting of two terms, like a plus b. Okay, so I'm going to give you how do we then multiply monomial with binomial. This is the property called the associative property. So it's like if you have a times b plus c, okay, this is equal to a times b plus a times c. So it is it's when we do a times b and then a times c. You can say plus or minus here and plus or minus 3. Okay, let's give an example. Let's say we have like two a open bracket a minus 1 close bracket minus 3 open bracket a squared minus 1. Now we're going to apply the law we learned earlier. So we're going to do 2a times a and then 2a times negative 1. Same also here, 3 times a squared and then 3 times negative 1. So 2a times a will make 2a squared. So it's like it's going to be 2a times a, okay, minus 2a times 1 minus 3 times a squared minus 3 times negative 1. Now 2a times a makes 2a squared, 2a times 1 makes negative 2a, and then negative 3 times a squared makes negative 3a squared, and then negative 3 times negative 1 will make positive 3. Then whenever we work out these algebraic expressions, we always check if we have like terms, okay? So now we're going to select like term. We can see we have 2a squared and then negative 3a squared. They are like terms because they both end with the same variable with the same exponent, okay, a squared. So this can be combined. That makes negative 1a squared minus 2a plus 3. Now, negative 1 is not written, okay, in mathematical expressions as coefficients. So we can just write a squared minus 2a plus 3. Like this, we simplify, okay, this algebraic expression. Now, multiplying two binomial expressions, okay? I'll move it to there. Okay, it is of the form, let's say, I'm going to give you an example. Ax plus b times cx plus d. Okay, those two are binomial expressions. So what we do, we're going to do, this is equivalent to say ax plus, no, c. The constant first, a times c x squared plus a times d x plus b c x plus I'm going to move this one over, so I'm going to take all this. Okay, the parentheses will come like that. Et voilà. So plus B times D. Okay. So now let's give an example. Let's say we have like 3x, let's say 3x minus 2 times by 5x plus 8. And they say simplify this expression. So this is what I'm going to do. I'm going to do 3x times 5x. Okay, this will be what? 3 times 5. I first do the coefficients, okay? Times x, that makes x squared. And then I do 3x times 8. So this will be plus 3 times 8 times x. And then I'm going to do negative 2 times 5x. So this will be negative 2 times 5 times x. And then negative 2 times 8. So that makes negative 2 times 8. So this will be 15x squared plus 24x minus 10x minus 16. Okay, when we multiply. Now let's see if we can combine like terms. So we can see here we have 24x and negative 10x. The two are like terms, so they can be combined, and the expression will then be 5x squared plus 14x minus 16. So we can say here we simplify this algebraic expression. Well, a trinomial then is an expression with 3 terms. For example, let's say ax squared plus bx plus c. If we count the number of the terms, they are like 1. This is a term, that's a term, that's a term. So 1, 2, 3 terms. Now, to multiply then a binomial with a trinomial, it is of the form like doing a plus b in the bracket times let's say c plus d plus e. Okay, we're going to apply the same distributivity law. So it's like a will times the bracket a plus c, c plus d plus e, and then same thing also b will be c times c plus d plus e. And then this can be simplified, extended when we times a times c plus d plus e, etc., etc. Now let's take an example here. I'll take an example, x minus 1 and times x squared minus 2x plus 1. Now, this is what we're going to do. We will say x times everything in the bracket here. So x squared minus 2x plus 1 minus 1 times also everything in the brackets, okay? 2x plus 1. So this will be x cubed minus 2x squared plus x minus x squared minus 2x plus negative 1 times 1 makes negative 1. Now we can combine like terms if they are. We have x cubed, there is no more x cubed, so this will remain x cubed. And then let's check if we have like the terms we squared. They are negative 2x squared and negative x squared. They can be combined, that makes negative 3x squared. And then we have positive x and negative 2x. They can be combined, they all end with x. They're like terms, so this will be equal to negative x. And then we have the constant term, that's negative 1. So this is the simplified form of this algebraic expression. Now, the product of two identical two or more identical algebraic expressions is known as the square or of that expression, or the nth power of that expression. Let me give an example. Let's say we have an expression here which is like a, and another expression is like a also. Then the product of these two identical expressions will be a to the power of 2. Similarly, if it was like a times a times a dot times a, this will be times a here, this will be a to the power of n. Okay, that's algebraic expression to the power of n. So the nth power of that algebraic expression. For example, let's say the expression is like 2x, okay, times by 2x. This is like 2x to the power of 2. And this can be simplified by saying 4x squared, okay? Or the expression is like x plus 1 times by x plus 1. This is called also x plus 1 to the power of 2, okay? So remember, we applied this law in math that says the law of exponent that says a to the power of m times a to the power of n. This is equal to a to the m plus n. So when the bases are the same, we add the exponents. Like here, the bases were the same, the exponents are just 1, we add the exponents. Okay. Thank you.